Hello, this is what I'm working in nowadays. I'm trying to change my OBAL board and substitute this checkout with the STM32. I mentioned that before in a previous video, but in this video I'm taking a step further. Let's review the hardware here. This is the Raspberry Pi Zero, and this is OBAL board, and this is STM32, the black pill. Let me show you. Here it is. It is STM32F411, and this is just two LEDs to simulate motor. It will light, it will glow when there is a PWM output signal, and this is to simulate RCN signal. I'm not using this checkout anymore. I'm not using this board. This board is used to generate PWM signal for the motor, and in the previous video I show you that I flew my quadcopter without the need of this board, using only STM32. But now also I removed the need of RC input. I'm not using RC input anymore on the Raspberry. I'm using it from this board, as well as the ADC here. There is an ADC board here that measures the voltage of the that is used to measure the voltage of the battery. I also embedded it in the STM32. So the STM32 now performs three functions. It generates output for the motor, and I said output because it's not only a regular PWM, but it can generate D-shot output and different outputs for different motors. And it reads PWM input RCN, and it reads from four different analog to digital converter. It reads analog signal and convert it to voltage. Now let's see the layout of the STM32 FR11 and how I chose the output. Okay, I needed RCN. Here it is, the RCN 1, 2, 3, 4, 5, 6, and I only could choose 4 output motors because of I'm using RCN and I'm using ADC. So here it is, the motor 1, 2, 3, 4. If I want to use more output motors, then I can use another STM and make it dedicated for motors only, and in that case I can use 8 motors. And now the ADC, here it is, the ADC 1, 2, 3, 4. Why I'm using ADC here, not here? Because when you choose RCN and motors and ADC, you need to make sure that there is no conflict between timers between RCN and motors, and I had to try different configurations, and this is the configurations that I can find it to work. So the timers are here. Can you see T2, C2? This is timer 2, channel 2, timer 5, channel 3. We will see now how to configure this in the code, and it's very easy. In the code you can define the motors like that. Define motor, define the timer, and channel the pin and use it as a motor. Let's see. It was P9 motor 1, which is channel 4, timer 4, channel 4. And here are the the PWM input. For example, this P8 timer 10 channel 1, use it as BWM. Here it is, B8 here, timer 10 channel 1. As you can see, I used here timer 4 for motor, but I didn't use timer 4 T3 for BWM. I used timer 10 so that there is no conflict between the timers. The remaining of the definitions are here. Here I use I2C. I select I2C pins. I use 3 I2Cs because each feature is a separate device. IDC, the analog to digital converter that is used for battery, is a device. So I used an I2C for it. Then the RC-in has another I2C, and the motor has another I2C. These I2Cs are here. This is I2C1, I2C3, can you see here? And I2C2, and I get it from here, I2C 2 B10 and B3 is here. I2C ZE2. Let me color it. Okay. So the I2C pins defined, and I add here an address. So because it is slave I2C, not master I2C, it works in slave mode. This is another address. And by the way, you can define 2 addresses. So if we try to go to the Raspberry here and run the I2C detect, we will find these addresses: 66, 27, 33, and 48. The 77 is the address of the baro on the OBAL board. This is the baro address. So it is 66, here it is, 27, 33, and 48, 33, and 48. So as we can see, it is up and running. We can see here the BWM input, and it is defined 6 because there are 6 BWM input. I attached RC out to I2C1, I attached RC in to I2C2, I attached ADC to I2C3. For sure I can change them from here. So these are the most important settings, and this, so you can play with this and change them. You can play with this also. You can disable the RC-in. You can, to increase the motor, so you can disable the RC-in from here and increase the number of motors, or vice versa. You can increase the number of RC-in and decrease the motors. The ADC input is here. Here are the pins. You can define other pins if you want based on this logic. You need to select from these pins, and then here this is important. You need to define the timers that you are using and the total number of timers here. As you see here, this is timer 3, timer 2, timer 1, timer 4. So here you are using timer 1, timer 2, timer 3, timer 4, timer 10, which is here. Here it is timer 10. So here You mention the timer that you are using. 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 is here. So remember, when you change the array here, you need to specify the number of items here and the number of different timers you need to specify it here. And that's it. Now let's go and run the board. Okay, as we can see, I run the Ardocopter, and as we can see, the STM32 RC out found 4 channels. The STM32 RC input found 6 channels, and the ADC STM32 initialized successfully. Now the board is running. This lets simulate the motors, and it's not on because I need to enable the motors from here. I mentioned that in the previous video. Here it is the signal of the motors. Now you can see them on. If we turn off the Ardopilot, okay, it turns, this LED is not flickering, is not blinking anymore, and this is not freezing, it is just waiting for the signal, and it shut down the motors to avoid running the motors without the board being running. Let's rerun the Ardopilot again. Here it is. You can see the signals of the motor is coming, and this LED tells us that it is receiving RC output and it is sending it to the motors. Here you can start it. This is not reset, this is enable and disable the RC out. This is my quadcopter. As you can see, you can find camera that is not used, LiDAR that is not used in our demo here. We need to focus on this. This is the STM32, and this is the orange receiver. The orange receiver is connected to the STM32, and the motors are speed controllers, as you can see, are connected to the STM32. This chip is not used, it is just soldered, that's why I didn't take it off. This is the RC in of the original OBAL configuration. It goes to the Raspberry, it is not used also. As we can see, I'm using the orange receiver, and it is connected to STM32 directly.